Okay, I think we're comfortable now with Newton's first law, so let's talk now about Newton's second law of motion. And this one can be the easiest and the most difficult at the same time, believe it or not. Newton's second law, and here's your objectives for the notes that you'll take, but we'll talk through them for each slide. Newton's second law tells us basically that mass, acceleration, and force are very closely related. Okay, and there's a really neat little formula that's usually pretty easy to calculate and find force, mass, and acceleration using the formula F equals ma. Okay, it's one of the most famous physics formulas out there. So here's our objectives, and let's go ahead and jump right in. Newton's law tells us that a body accelerates when acted upon by a net force. Okay, and we've seen that. We've seen that in our simulations that an object, in this case the crate, will accelerate when there is a net force. Okay, and here it comes there it's that green net force. Okay, that's the sum of those forces, and there it's accelerating in the negative direction because of the friction. So in both cases it's accelerating because of that net force. Okay, and I think we're pretty well established on that idea. Now the acceleration of that object will be directly proportional to the net force. So what does that mean? That means that net force, in this case it's to the left, it's the friction that's opposing the motion of the crate. Directly proportional means that when the net force increases, the acceleration increases. Or in other words, if this force is doubled, then the acceleration of that object will be doubled. Okay, that's directly proportional. So the net force is directly proportional to the acceleration of the object. When one is doubled, the other is doubled. If you cut the net force in half, the acceleration would be cut in half. That's directly proportional. Newton's law also tells us that acceleration is inversely proportional to the mass of the object. So if we increase the mass of the object by twice as much, okay, so this refrigerator, it's got twice as much mass now. If I apply the same force to it, then it will accelerate half as much. So by doubling the mass from 100 to 200, but applying the same force, the acceleration will be cut in half. If the mass is doubled, the acceleration is cut in half. Okay, if the mass is cut in half, what would happen to the acceleration? So now I've cut the mass in half to a file cabinet from 100 to 50. Now the acceleration with the same force would be double. Okay, and that's inversely proportional. When one goes up, the other goes down. When one goes down, the other goes up. So that's an inverse proportional, and that's the relationship between mass and acceleration. When one goes up, the other goes down. Okay. Here's a more technical look at Newton's second law. We said it's F equals ma, but it's actually the vector sum of, and that's what this little symbol sigma means in math and science. It means the sum of, or the vector sum of. Okay, and again, that's what we talk about when we see this green arrow. So the vector sum of, let's show it here. So there's the vector sum of the forces at work on this file cabinet. In this case, they're working with the motion, with the force in the direction of the force, or in the direction of the force in a negative way if it's friction. Okay, so that's the vector sum of. Acceleration is directly proportional to the vector sum of those forces, and that's that green vector there. Okay, so acceleration will go in the direction of that vector sum. If it's slowing down, that vector sum is opposite of the motion. If it's accelerating in the positive direction, that vector sum will be in that same direction. Okay, so the vector sum of, that's what that symbol means. And of course, newtons is n, mass is in kilograms, and acceleration is in meters per second squared. Okay, so let's practice a little bit. When you practice your Newton's second law problems, these are your steps. You want to set up the equation, you want to identify the numbers, and then just plug and chug, and it's usually not too difficult. So let's practice on some of these sample problems. Let's first do this first one. A force of 800 newtons is applied to a 400 kilogram refrigerator. What would be the acceleration? Let's take a look here. We've got an 400 kilogram refrigerator and we apply 800 newtons of force. What would be the acceleration? Okay, well, F equals ma, okay, and our vector sum of the forces is 800. So let's write that in. So our F is, 800. Okay, that's our force, equals our mass, which is 400 kilograms. But we need to know what A is. Okay, so how would we solve for that? We want to divide both sides so that we can isolate A. Divide both sides then by 400. Okay, because we want to solve for A. So divide 400 on this side, divide 400 on this side. Okay, this will cancel. 400 divided by 400. 800 divided by 400 is 2. So our acceleration would be 2, what's our units? Meters per second per second. Okay. Just a real quick review about acceleration, because we always kind of need to understand acceleration because it can be a bit tricky. Let's take a look here at a visual that I think will help you. If you talk about acceleration with something from free fall, of course, gravity is the force acting upon it. It is a net force. There will be some wind resistance, but things do accelerate when they fall. And this is kind of what something would look like as it falls. So because it's under the force of gravity, which is a net force until air resistance might balance that force of gravity, but things do accelerate. And free-falling objects accelerate at a constant of 9.8 meters per second per second. Okay, so that just means after the first second it would have traveled 9.8 meters, or it will be traveling at 9.8 meters per second, and this is not to scale. After the second, it will be traveling with a velocity of 19.6 meters per second. And then after the third second, it will be traveling 29.4 meters per second, and so on and so on. So that's just, I think, a good graphic to help you understand acceleration, especially acceleration due to the gravitational force that's constantly on objects here on Earth.